Sometimes you've just built a Linux kernel and you want to be able to debug that, or perhaps you're working with physical hardware and you're seeing an issue. Perhaps you're remotely booting a custom kernel or just a new kernel, and you want to be able to reproduce an issue you're seeing. Perhaps you've got the kernel and you've heard about qemu, or however you say it, qemu, and there's various options to qemu, which can be a little bit confusing. And these settings are particularly useful for when you're starting a Linux kernel and you want to be able to step through and really see what's going on with the kernel options. So if I just focus in on these, um, so I've got a little kernel that I've prepared here. There's also a minimal kernel repo if you need just a minimal kernel as an example, or just follow the there's an excellent README here and follow the video for building your own Linux kernel. But anyway, the focus is on these options, these various options to enable KVM makes it a lot faster. Without that, it will fall back to a software-based emulated CPU entirely, and it won't take the benefits of your CPU's virtualization technologies. The key bit though here is the serial monitor standard I/O. The monitor is a QEMU concept. And here we're going to also add to the kernel, we're going to append this console equals tty serial 0. And that relates to, since we're using the serial above on line 26, it appends. I'm going to take that off to begin with, just to show the difference. So I'm going to save that now. And I'm going to run this QEMU. Notice that obviously we're passing the kernel in the VM in the kernel argument, and we're passing the initrd as well. The CPU is pretty self-explanatory. Actually, it's not really actually. So CPU max enables all the features supported by the accelerator on the current host. The accelerator in this instance is KVM, and the notes are there. Anyway, I'm going to run this thing to use QEMU to boot. And okay, it's starting up, but we don't see anything. And that's a bit of an issue, right? Because we can't see the kernel boot up. And what you might do at this point is you would use graphics. Perhaps you've seen that on various forums. You might see display equals curses, I think is the option. If you don't know those options as well, there's that help feature that you can use. But perhaps you do Control C and you get stuck. And how do you get out of this window? So on this Linux operating system that I'm on, the keyboard bindings for that, I'm pressing Control A and then X, and that will take us out of the QEMU monitor. You can also get back into it, obviously by restarting, and I'm just going to correct what we just did there with the none and go back in. If you can do Control A C, it will switch between the monitor and the serial. So here we are in the QEMU monitor. We can type help to get more information and obviously read the manual. But we can do Control A C again to jump back to the console of the machine that we're actually running. But we can't see the kernel messages, and that's a problem, right? So I'm going to do Control A X to kill that instance. And now I'm going to re-enable this append. And I'm going to run again our script. And this time we'll see all the useful information for the kernel. So the kernel's booting, and of course this is a much more friendly, pausable view where we can, in our own time, we can scroll through and reliably repeat the process of debugging our kernel options. Because perhaps we want to add additional kernel options and experiment with where that's going wrong. And perhaps we can even step through kernel boot process. Okay, so in this particular instance, yeah, we've got an emergency situation with the kernel. It's just